All right, class, this is going to be your pre-lab for calorimetry, in which we will measure heat transfer in an isolated system, pseudo-isolated system, to determine with accuracy and precision the specific heat of water. So this is not so much a problem-based lab as much as it is a test of your ability to follow the procedure and get accurate and precise results, considering we already know the specific heat of water is 4.184. So we'll see how you can do. First step in this one is going to be to create a coffee cup calorimeter. And this is essentially set up as a double styrofoam cup. So you're going to take 2 cups, stack them one on top of each other. Then you're going to cut the little rim off of a 3rd cup, and this is going to be your lid. So again, these are really good calorimeters for what we need to do. Certainly bomb calorimeters have some more technicality to them. They're not made out of styrofoam, but we've already had these discussions about why styrofoam is an excellent choice for calorimetry, because it's an excellent insulator, which is the opposite of a conductor. So first step you're going to do is to weigh your calorimeter empty so that you can take a weight by difference. So I'm going to pour my water back out for the time being. It's nice and dry. And we're going to weigh our cup. Lid or no lid is personal preference. I'd say without the lid is probably the way to go, just in case you destroy the lid, or it just makes weighing it easier at the end of the day. So you're going to document that value, 3.999, on your data table for the empty cup. Then you're going to add approximately 125 milliliters of water to your cup, and we are going to weigh this by difference. Okay? Anywhere from 100 to 125 ml is proper. It does not need to be exact. The only thing that matters is that you have accurate data, so that you can, again, take the weight by difference. I would encourage you to use the analytical balance in this lab so we can grab the extra sig fig, but that's first step there. Over on my hot plate over here, I already have my metal being heated in the boiling hot water bath. So I'm going to come over here and bring my calorimeter kind of like near my water station. All right, so this has been boiling and in the water for about 5 minutes. 5 to 10 minutes is sufficient. The longer you let it go, the more likely it is that your metal is equilibrated with the water. But certainly we don't want to sit here for 30 minutes allowing that to happen, because again, it's probably achieved after 5 minutes. You're going to take a thermometer and measure the temperature of your boiling water. Now, we know that boiling water at our elevation is 99.8. These thermometers have not been calibrated in a little while. That's really not an issue, to be honest, because you're going to use the same thermometer throughout the experiment, meaning like any fluctuations or discrepancies in the calibration of your thermometer is going to work in both directions. So, if it's reading slightly low, well, it's also going to measure your final, temperature of your water a little low as well. So it kind of self-corrects for itself in that manner. The only thing that matters is that you use the same thermometer through all of your trials, okay? So this one, working very nicely. This is 99.8. That is exactly what we were expecting. And that would be the initial temperature of your metal. So we assume that the metal is in thermal equilibrium with the water. So then when you go to measure the temperature of your, combination of the metal and the water, the trick is twofold. You want to first make sure that your thermometer is actually touching the water. And essentially, this gets inserted from the side here. If you start it from up here, then it's likely you're actually not even going to be touching the water. So that's a common mistake, that you think you're actually measuring, but it's not actually touching. So make sure you take that. Additionally, when you put the metal in there, you really don't want it to be touching the thermometer. And that one is a little bit harder to mitigate because it's not transparent. But if you drop the metal in and you don't shove the thermometer all the way down to the bottom, then you can be pretty certain that you're not touching the metal. Additionally, you can kind of feel you're gonna stir this material around a little bit. The water as you're allowing it to reach thermal equilibrium. That is the metal with the water in the calorimeter. And you can kind of feel whether you're touching it or not, all right? So I'm gonna insert my thermometer in through the side here, like so. Okay. And take an initial temperature of your water once it's stable. Okay. So you have an initial temperature of your water and you have an initial temperature of your metal. So real trick here is to quickly transfer the metal, right? That is the hardest part of this lab, and you know, a proper assumption that there's going to be some error introduced right away because of the transfer, but if we do it quickly, then it's truthfully not that much of an issue. So I'm going to pull this a little bit closer to me actually. Okay. Be careful when you're messing around with this water. Boiling hot water will absolutely burn you. You're gonna be nice and careful there. Okay. And obviously you kind of see my setup. I have a test tube holder connected on there. It's like hovering in there. All right, so one person's gonna open the cup, the other person's gonna transfer the metal. Just one shake, and it's in. Okay. I'm gonna stir my metal around a little bit, my water, I should say. You're gonna document the highest temperature, okay? So you're gonna stir it, stir it, stir it. Try to make sure you're not actually touching the metal, okay? Just wanna be touching the water there. And again, like I said, you're gonna document the highest temperature. So it's gonna go up. You know, counterintuitively, this water's temperature does not go up as high as you're expecting it. There's a reason for that. It's a small piece of metal, and the specific heat of the water is rather high. Therefore, you know, like we said, it takes a lot of thermal energy to increase the temperature of water. Therefore, temperature change will always be somewhere in between the two materials, that is the metal and the water, but it won't go up nearly as high as you're kind of expecting it to. A couple nice little stirs here kind of like distributes the thermal energy equally throughout the system and the surroundings. And like I said, you're going to take a final temperature of the water where it peaks. So I would be documenting 22.5 here. The pure metal that you're using in this laboratory is 10, whose specific heat can be referenced. Make sure that you take all your data in pen for this laboratory, and there will be bonus points for getting your percent error, let's say under 5% for the specific heat of water. That's pretty much wrap on this pre-lab. Good luck with it. Ask questions if you got them.